In this lesson, we're going to be looking at the side length properties of triangles. And we're going to be looking at determining the angle properties of triangles, and determine the properties of triangles related to side lengths. And we're also going to relate the side lengths and angle measures of triangles. So the outcomes we're going to cover are: first, describe and illustrate side length properties of triangles. Identify and explain an application of the properties of polygons in construction, industrial, commercial, domestic, and artistic contexts. And solve a contextual problem that involves the application of the properties of polygons. In any triangle, the following properties apply. So it doesn't matter which triangle you're looking at, these will be true. The side opposite the largest angle is always going to be the longest side in that triangle. If you have an obtuse angle, for instance, in your triangle, the longest side in the triangle will be opposite that obtuse angle. And when I refer to the opposite side, I mean the side that does not touch the angle at all. The other two sides in the triangle are the two sides that make up the vertex for the angle. The opposite side is completely separate from that angle. And the side opposite the smallest angle is the smallest side. So the side opposite the largest angle is the longest side. The side opposite the smallest angle is the smallest side, or shortest side. So if you have a middle angle, the middle side length in that triangle will be opposite the middle angle. And this is also important. The sum of any two sides in a triangle must be greater than the length of the third side. So that has to be true all the time. So we're going to start with an example. Determine the relationship between angles and side lengths in triangles. Kathy is a landscaper. She is creating a design for a client's backyard. The client gives Kathy the measurements for the existing triangular garden. How does Kathy know the measurements are incorrect? So we're going to check that whether or not they're correct based on the properties that we just discussed. So once again, that side opposite the largest angle is the longest side. Side opposite the smallest angle is the smallest side. And thirdly, the sum of any two sides must be greater than the length of the third side. Well, we don't know anything about the angles right now in our diagram, if you look here. So the first two properties are not going to be of much use to us right now. But the third one says that any two sides in a triangle added together must be larger than the third side. So that's why we say here, any two sides in a triangle must add up to be longer than the third. Well, look at the two shorter sides in this triangle. If we add them together, they're 2 meters and 3.4 meters. So we have 2 plus 3.4, and that equals 5.4 meters. But you'll notice that the longest side in this triangle, as it's described in the picture, is 5.9 meters. So 5.4 being less than 5.9, there is no possible way to properly create this triangle. As a result, the measurements are incorrect. Okay, Kathy asks the client for correct measurements, including angle measurements. So not only does she want the sides fixed, but she also wants the angle measures this time. How does Kathy know that the client made another error? Well, you'll notice at this point that the longest side in the triangle is reduced to 5.1 meters. So if we add 2 plus 3.4, we got 5.4. And that means that those two sides will actually be larger than the third side. So now the side measures seem to be correct. or at least they are possibly correct. They fit the property. But now we're going to look at our angle measure properties. And if you recall, the angle opposite the shortest side in a triangle is the smallest angle in the triangle. So the shortest side in this triangle is 2 meters. And we also see that the angle opposite that side is this angle right here. Okay, that's the angle opposite the 2 meters, because it's the 2 meter side doesn't touch that angle whatsoever. So that means that the side opposite, or sorry, the angle opposite to this side is 25 degrees. But you'll also notice in the top right corner of this triangle, if I can find here, okay, the top right, or sorry, top left corner of this triangle has a 15-degree angle. So that's the smallest angle as measured. The smallest side is 2 meters. The smallest angle appears to be 15 degrees. But the 2 meter side is not opposite the 15-degree angle. So the smallest side is not opposite the smallest measured angle, as it's drawn here. So that means there must be a mistake as well. Okay, so to summarize, this was a short lesson. Remember that the side opposite the largest angle in any triangle is the longest side. And the side opposite the smallest angle in any triangle is the smallest side. And finally, for any triangle that you will ever draw, if you add together any 2 sides in that triangle, they're going to be larger combined than the third side. And if that is not true, that means that you've either measured your triangle wrong or you haven't drawn a triangle at all.